Hello viewers, I am Himal Kobir. We are presenting our research on NFT investor behavior during market boom and slump, and we want to start by clearly explaining what NFTs are, how this market works, and why our research problem is important. First of all, what is an NFT? It stands for non-fungible token. Unlike cryptocurrencies such as Bitcoin or Ethereum, NFTs are unique digital assets recorded on the blockchain. Each NFT represents ownership of a specific item, most commonly digital art, collectibles, game items, or virtual land. And we people generally trade valuable items to make profit. So this particular digital asset needs a certain kind of marketplace of its own to buy and sell. NFTs are bought and sold on NFT marketplaces such as OpenSea, CryptoPunk, CryptoKitty, Bored Ape Yacht Club. These marketplaces function similarly to traditional markets. Creators mint NFTs, buyers purchase them, and later those buyers may resell them, hoping to make some profit. Now let's talk about how the NFT market actually behaves. During 2020 to early 2022, the NFT market experienced a massive boom. Prices rose rapidly, daily trading volume exploded, and NFTs were widely promoted on social media. Many people entered the market driven by hype, fear of missing out, and stories of overnight profits. However, this boom was followed by a sharp market downturn or slump. NFT prices declined, liquidity dropped, and many investors were left holding NFTs worth far less than their purchase price. This created a situation where different investor behaviors led to very different outcomes. Some investors exited early and profited. Some sold quickly but at loss. Others held long term, either benefiting from recovery or suffering prolonged losses. This leads to the central motivation of our research. Can we understand and predict investor behavior in the NFT market using real transaction data? To answer this, we used a real-world dataset from Kaggle titled NFT Initial and Subsequent Sell Data in Boom and Slump. This dataset contains NFT transactions from OpenSea Marketplace, including initial purchase price, resale price, transaction timestamps, collection date, and metadata. Importantly, this dataset covers both the boom and slump periods, making it ideal for studying how investors behave under different market conditions. Our goal was not to predict NFT prices directly. Instead, we wanted to create a clear behavioral classification so that at a glance anyone, such as finance students, tech professionals, or business investors, can understand should they invest in NFTs or not. If they do invest, what kind of strategy works best? And most importantly, what kind of investor behavior leads to better outcomes? To answer this, we designed a machine learning pipeline that classifies investors into four distinct behavior types based on entirely on real historical data. With that context, now I will explain how we formulated this problem and constructed our target variables starting from prior research. Before this work, most NFT-related studies focused on price prediction, network structure, or short-term hype. Some researchers assessed the functionings of NFT marketplace. For example, Nandini and others analyzed NFT transaction networks and bubble formation. Dowling showed that NFT prices are significantly more volatile than Bitcoin. Until-linked NFT prices with social media attention, but only for short-term movements. In crypto behavior research, Christopher separated long-term holders from speculators, and Makarov showed that retail investors tend to panic sell during market crashes. However, none of these works classified NFT exit behavior during market downturns. That is the research gap we address. Instead of predicting price, we predict investor behavior. We define our target using two measurable quantities, holding duration and profit or loss. Holding duration is computed as the difference between resale and purchase timestamps. Profit percentage is calculated as resale price minus purchase price divided by purchase price. Using these two values, we classify each investor into four behavior classes: smart flipper, panic seller, time on hands, and bag holders. This framework gives us interpretable and actionable labels rather than abstract numeric targets. Now I will justify why do we choose 90 days threshold. A critical design decision in our study is defining what constitutes an early exit versus long-term holding in the NFT market. To determine this, we empirically tested multiple holding period thresholds: 30, 60, 90, 120, and 180 days. We evaluated their impact on class separability and profit differentiation. Among all tested thresholds, 90 days consistently produced the strongest results. Specifically, the 90-day cutoff achieved the maximum profit separation of 24.6% between short-term and long-term holders, maintained a balanced class distribution avoiding exchange skew, aligned closely with observed on-chain market behavior where profitability declines as holding duration increases. This trend is clearly illustrated in the profit versus holding time figure shown in the slide, where median profit decreases steadily beyond the 3-month mark. From a blockchain and crypto market perspective, we trust this also supported by prior work and industry practice. Studies on crypto investor behavior such as Christoph's analysis of speculative versus long-time holders shows the short-term holding period captures speculative dynamics, while longer horizon reflects fundamentally different behavior. Similarly, McCullough demonstrated that retail investors tend to exit positions within a few months during market stress. Industry standards reinforce this distinction. For example, Glassnode's on-chain analytics commonly separates short-term and long-term holders using holding time thresholds, and tax frameworks such as the IRS short-term capital gains window use a comparable temporal boundary to distinguish speculative activity. Therefore, the 90-day threshold in our work is not arbitrary. It is empirically optimal, behaviorally meaningful, and consistent with both academic literature and blockchain industry convention.
Hello everyone, this is Sevan Kumar Shah Tirtho here. First, let me talk about the dataset and preprocessing. We collected over 1,62,775 transactions from OpenSea, which covers about 70% of the secondary NFT market. To make the analysis more accurate, we've refined this data and kept only 92,624 subsequent sets. This allowed us to correctly calculate holding periods and profits. We also ensured data integrity by converting all prices from O to ETH. To handle extreme values and noise, we used median imputation, which makes the dataset more robust and reliable. Next, I will try to explain methodology, especially the anti-leakage framework. To avoid data leakage, we removed final sale price and profit information from the input features. This prevents the model from accidentally using future information. The model only uses data available at the time of purchase, such as price, royalties, and trading volume. Our main goal is not to predict price, but to understand how buyers behave, such as whether they exit quickly or hold for a long time. Now, let me explain the results shown in the graph. On the left side, we can see that shorter holding periods, especially under 90 days, tend to give higher profits. After the 90 days threshold, the profit rate generally declines. On the right side, individual transaction data also supports this pattern. The red dashed line shows the 90 days threshold, which clearly separates quick exit from long-term holding behavior. Overall, this result justify why we use 90 days as a meaningful boundary to classify investor behavior in our study. Now I will briefly explain how we prepared our data and improved model performance. First, let's talk about feature engineering. We designed 17 key by-time signals that captured user behavior at the moment of purchase. These features combine purchase history, collection behavior, and behavioral indicators. Importantly, we didn't use any holding period on profit information directly in the target level, which helps prevent data leakage and keeps the model realistic. Next, we address the issue of class imbalance. Our dataset is dominated by flippers who make up about 58%, while diamond hands represent 10%. Without correction, the model would simply favor the majority class and miss long-term holders. To fix this, we applied synthetic class weighting, which penalized majority class errors and rewards the model for correctly identifying rare but valuable archetypes. Finally, we handled data normalization. Some features like trading volume have very large ranges and can overpower smaller binary signals. This especially affects model like logistic regression and MLP. We solve this by filling missing values with the median and applying standard scalar, ensuring all features have zero mean and unit variance. This stabilizes gradients and improves learning. Together, these steps create a balanced, fair, and robust modeling pipeline. Thank you.
And this brings us to the bottom line. Behavioral prediction isn't science fiction anymore. With the right data and right models, we can actually see the exits before they happen. This is Rudrojyoti Moitra Soham. I'll now conclude by discussing what we found, why it matters, and how it connects back to blockchain research and real world NFT decision making. Among all tested models, XGBoost clearly outperformed the others, achieving approximately 86% accuracy and 84% macro F1 score, representing more than a 10% improvement over the baseline logistic regression. This confirms that NFT investor behavior is nonlinear and influenced by interacting factors rather than simple thresholds or linear rules. Looking at class level performance, the model performed strongest on smart flippers and diamond hands, while confusion primarily occurred between short term loss exits and long term loss holders. This is expected because at purchase time, future profit direction is inherently uncertain, even if behavior tendencies are predictable. The most important insight emerges from the feature importance analysis. Nearly half of the model predictive power comes from just two features: whether the buyer paid a premium relative to the collection average and the historical quick exit rate of the collection. These are collection level signals, not individual timing choices. This directly supports findings from prior NFT and crypto literature. Studies by Nadini shows that NFT markets exhibit strong herd behavior and clustering, while Dowling demonstrates that NFT volatility is driven more by market structure than by individual asset traits. Our result empirically confirms this by showing that collection, reputation, and historical behavior dominate individual decision making. Interestingly, buying during hype period contributes far less than expected, reinforcing the idea that entry discipline matters more than timing narratives. This challenges common retail intuitions and aligns with finding more findings from Markov and scores who shows that retail losses during downturns stem more from overpayment than mistimed exits. From practical standpoint, our findings offer actionable insights for investors. The takeaway is clear. Evaluate collection stability, exit behavior, and price discipline before entering, rather than relying on hype or short term momentum. For platforms and marketplace, these signals can be surfaced as risk indicators, helping users make more informed decisions. From a research perspective, our framework demonstrates that behavioral prediction in blockchain markets is feasible using only pre-purchase information. With this, which is critical for real-world applicability. There are limitations. Our data is centered on a specific market cycle and excludes off-chain signals such as social media sentiments. The 90-day threshold, while empirically justified, may vary across chains or future market conditions. These limitations point naturally towards future work incorporating multi-cycle data and hybrid on-chain and off-chain features. To conclude, this work shows that NFT investor behavior can be predicted with high accuracy using disciplined, leak-free machine learning. More importantly, it demonstrates that structure beats psychology. Collection level dynamics matter more than individual speculation. This insight extends beyond NFTs and offers a template for understanding behavior in other volatile digital asset markets.